Namaskar, good morning, good day. Assalamu alaikum, Sat Sri Akal. This is Engineer Suraj Singh speaking from Bharat, India. On this day, June 30, 2020, in connection with routine talk about brief on COVID, brief on COVID, and then details talks on management, engineering site management, project management, and materials like concrete soil, and also something on in say contracts, FIDIC like general talk as usual for information and dissemination of whatever is available to my friends. Of course, it's long video, but talks can be made in brief. If you want to really learn something, then minutes and hours do not matter. You have a privilege that you can read this, you can use this video a number of times, if not in one go. You can use 10 minutes, 20 minutes, 30 minutes as you like, and continue to watch it at your facility, at your choice, at your pleasure. But I am bound to complete it in one go because there is some pause in this. Nothing as such can't be paused, and that's what I'm saying. COVID-19, dangerous, powerful, world beater, human killer, is working without fail, punctual, regular, and invariant. This COVID is for everybody. It's not afraid of anybody. It's very powerful, so powerful. We can't say whether this is either of devil or God. It can be both. It can be one or two means, because it's not easy to understand God. Similarly, it's not easy to understand what is devil. Both are powerful. Both are strong. Very strong. If you compare to human, very strong entities these are. COVID-19. Sometimes we think we are sleeping or COVID is sleeping, and sometimes we think that COVID is working. It happens, confusing whole world, and that's what policy of COVID is. That is what policy of COVID is, to cheat whole world. This is what COVID is doing, cheating and misleading all world population. People want to divert attention, but it's not allowing divert attention. People want to talk of economy, but COVID is standing in between. It's not listening to anybody. It should not. Such a powerful entity it is, because it's not. It's outstanding. It's extraordinary, beyond control of humanity. Its appreciation for COVID-19 and its depreciation for human, because to some extent human is responsible to create it. You can say by abusing earth, by abusing natural resources, and by pollution. To some extent I can say COVID is also a contributory entity of that. Well, just to speak only, no conclusion, no result. What's happening around the world, we know that this virus is spreading like anything. People think it has gone, but it comes back. It's seen again and again and again. This is such a guard, such a watch guard, that it doesn't go from its duty. It's very good in its duty, and we should learn from COVID-19 about our responsibilities. COVID-19 is exposing its responsibilities in an excellent way and telling us how to do like that. COVID-19, people think it has gone. They open their back, their box, the economies, but it comes again. So from overall, from general lockdown, they will do local lockdown. So keep on doing like this lockdown, that lockdown, here lockdown, there lockdown. But COVID is not going to be locked. It's not going to be locked. It's there for everybody. In England, Lancashire is locked again. Also in many other countries there have been actions like that. In our country too, Bharat, India, it's spreading like, like dying, like a bullet or missile. I don't know what we say. It's moving like Tandav. It's making Tandav. It's Tandav. Tandav, you understand? High profile, vibrant dance. Highest profile, vibrant dance is called Tandav. Means it's so powerful that it is stirring earth. It's stirring humanity. That's what COVID is doing. And I think generation must learn from this. Old, new, all must learn from this. COVID says, I am there, forget your economy, but we say, no COVID, you go, we concern our economy. That argument is going on between nations and COVID-19. This argument, how long can we argue like this? I have no answer to that, because COVID-19 is much more powerful than what we expected it or what we conceived. And still we are too small in our minds all over the world. We can't say where God's minds is or where minds are and where nature minds is. We think we are mind intelligent, but I think that we are still not intelligent. We are very small people because we are product of God, and God does something. We can't understand that. Means COVID-19 is still working, and people think it shall go soon. They are all in dreams, speculating. We should not do. We have to face it and face it. That's all I can say. What WHO says, what it doesn't say, doesn't matter. What is seen is matter. In Bharat, it's a population of 135 crores people, 1350 million people here. It's very effective now. You remember when we did lockdown in March first time, there were around 300 to 400, 500 cases of infections, and same number of cases have gone beyond 500,000, or maybe somewhere between 500,000 and 600,000. This is official figure, and I don't trust any official figure from whatever country all over the world. People all lie to some extent. German lie to 90% extent. Similarly, America lied to probably 80% extent. And we are lying about to say three times probably. What is happening? We are telling 1/3 of that, 1/4 of that. If we are telling we have 500,000, this means definitely it should be 2 million. I can say, similarly, America is having 20 million cases. So you can say all over the world it's around 1.5 billion people have been affected by this. This point we should keep in mind. Otherwise we are in wrong page. We are not on the right page. I should say that if you don't think now, we can think in future. There's no other time to think. If we don't have help, means whatever economy we open, that got no meaning except political persons, because they have to survive in their positions. Irrespective of people die. Factual is that, again I say, it's my allegation on all politicians of the world that they are exclusively interested in economies and not on health of public. Not in the health of public. They may something, saying is one part and doing is another part. So I'm not going to talk much on COVID today, because it's working. No way out. It's working. I can't stop it, and no one can stop it. People are affected. Now it looks as a very normal news, means okay, so many have taken, fine, it's affected. Means it's very normal now. because some news that keeps on coming for about, it has kept coming for about more than 6 months, 7 months, 8 months. So now it's the routine news, means it's not anxious me when nobody's having anxiety. Wait for this news as if some extra news coming. They know that they say one crore people or 10 million people, but I say many crores. I should simply say that there's no definite numbers, but around 1.5 billion people are affected, because there are people, a large population. Although there are asymptomatic people who demonstrate small symptoms, and they too are patient or infectious individuals of this virus. Probably I could be, I don't know. Whoever could be, can't say. But only outcome is that you have to take precautionary measures, and that's it, nothing else. So now we will move to further studies, because there's no meaning every time saying something about COVID, same and same. You know all well. It's no means no public knows what is COVID is, and what I'm saying is that about management. We come on to management. This management and project engineering management, total quality engineering, project engineering management, and total quality, which is a very important point from my aspect and your aspect, everybody's aspect. We will start with this now: project engineering, organizational management, and quality engineering, and then I'll shift over to some other portion of this, and that is what's to call it, QCS, we can say specifications. QCS just the Qatar civil specifications. Conclude how generally we are talking, and probably will shift to soil testing, which has been very important part in civil engineering, construction engineering, design engineering, without which nothing can move. Okay, all otherwise is fictitious. If you don't refer to soil, everything is fictitious. It looks fictitious. So soil is a big game, technical game and requirement, which dominates decision making of foundations. That's an important point, and we should say that. Talk of that in this concrete channel, and then after this we will talk about we can say FIDIC. After that, FIDIC 2017 will continue red book and silver book. Red and silver books will continue. So let's move further now. Let's start off. We'll talk of this management will continue now. Project engineering management, total quality engineering management, organization, which you can say its scope goes to all subjects of engineering, and not only engineering, also to life, because civil engineering is not just engineering, it's life of individual, how life is affected because of development by civil engineering. How does it affect human being, citizen of every country? Every citizen of every country, human being, are affected by civil engineering management, civil engineering field, you can say. We are organized in society because there is a society. That's a fact. If we are social, because there exists a society, and the society is just constitution of human being. It comprises individuals, all classes of individuals, male, female, and others, educated, illiterate, and those Education is one part, that's part of quality of a person. But involvement in development, involvement in evolution of society, to develop evolution and progress, that's important. I'm talking about engineering management, engineering organization, because engineering, and in particular civil engineering, is related to each and every citizen of this country. That's a fact. In a sense that every person uses products of civil engineering. Every person. There's no one, no two. Every field, wherever you go, from morning till evening, throughout your life, you'll find something where involvement of civil engineering exists in majority percentages, cost-wise and scope-wise. You walk on road, you walk on pavement, you walk on railway track, you go to railway track, stay in platform, you stay in house, go to offices, go wherever you want to go to toilet, take bathroom, or go to airport. There's no place, go to temple, mosque, or wherever you want to go. Civil engineering you are using, civil engineering products you are using, still you are using, sitting in the room, you are using civil engineering product. Because if there is a room, it is because of engineering management, engineering organization. If you understand this point, you can very well understand value of engineering. Frankly speaking, when we say civil engineering, this means this is real engineering. Real engineering, not because I am civil engineer, I am saying that. Civil means society. Civil means public. This is civic sense, we say. No civil sense, civic sense we say. Say or not? This is public. Civil is actually public. Civilians say that. Civilians means where military is not involved, means bomb is not involved, bullet is not involved, means you are involved by talks, by writing, by work, by hard work, by your activities which are normal, peaceful activities which don't need any war, which don't need any but intellectualism and work. That means the physical work, mental work. That's what civil is. And civil means, along with civil, integration of mechanical, integration of electrical, integration of electronics, integration of many other branches of engineering, other engineering. Civil engineering is not in isolation. Civil engineering is of course very rough field. It's too rough, I can say. Too rough, like it's walking on the road, you find stones and there's rough road, there's nothing, not even road, pavement, only path, only you walk, you drive. You are taking your car in a place, in a path where there's no road, nothing, and you are driving your car. Is it possible? It's not possible. Even if you walk yourself, you find very much difficulty. If you walk on somewhere where there's soil particles, stone particles, you are walking on them, you find difficulty in walking on that walkway, or on that you can say pavementless area, natural soil, natural ground. Friction exists that much between your soul and surface of earth. That is too much, and you feel you have to apply more efforts to walk on that. But if you walk on the road, or you walk on a plain surface, smooth surface, you won't find that much aggression in walking. Even if a plain surface you are racing on a grade, you will not find that much problem. But when you walk on a rough area, terrain, where there is no surface that's even, or there is no plain surface, you will certainly find difficulty in walking. You have to spend more energy on that, and you know, you can understand there if you walk. You can understand real value of engineering. That friction is there, which you have studied physics. There is a coefficient friction, and it's high, maybe 0.8, maybe 0.9, maybe 0.7. So when you multiply your weight with that coefficient friction, you get your horizontal force you are applying to walk. So you can yourself calculate, say it is 0.8. I say coefficient friction 0.8 between the sole, your leg, your feet and ground. So, and you are say 80 kilograms, so 64 kilogram you have to apply force while it's acting horizontally. So you have to work with that force. But same way, if you are too light, you have to apply light force. If you are too heavy, you have to apply heavy force. Why I am giving this example? Because I am just trying to explain to you, where does engineering start? Where does civil engineering start? No mechanical engineering here, no electrical engineering here, and no other branch of engineering except raw work of, you can say, raw work of civil engineering. We'll reach to other engineering later on, but civil engineering is zero engineering. We have to start from scratch. When you say scratch, this means this is the foundation of civil engineering. So we can define civil engineering in a different way to your mind, what you think of. You can say civil engineering is a toilet. Yes. When I was too small, means young, I was taunted by some people. They knew that I was in field of civil, though I did not complete that time. I completed my first diploma. Of course, I am not great. I am very weak student. So anyway, whatever it is, some people used to call me, because in those times people didn't understand everything. It was 1970s, and so all the toilet engineer is, and just to tease someone, toilet, your Hindi language is called something else. I don't want to speak that here. It doesn't look nice, but this is some, everybody, when you are small, people say like that. So you are not passed, but they start telling you he's an engineer, just like somebody's medical college telling you, oh, he's a doctor. Just like social interaction like that. Still I remember those times when I was called by that name, toilet engineer, or you know what I sense, stool engineer. That was the stool engineer he is, and it was teasing word. I didn't mind that, but you enjoy that also, because that is a fact of life. There is nothing, there should be a toilet at least. So that's your job as a civil engineer. That's not job of mechanical, electrical engineer, someone else. Even if in these days you install that in ready-made cubicle, then you have to do it somewhere. Otherwise, you have to fix everything from first principle and make it. So even though you make a starting or make own septic tank, you have to do it. How you do it depends upon you. But that's a fact. Means civil engineering starts from scratch, roughness. Civil engineering is rough basically, but delivers, finishes. Civil engineering is very, very rough in start, in birth, but delivers finished products. That's beauty of civil engineering. You start with something, bad terrain, but you deliver something beautifully landscaped. You understand that? Roughest terrain, roughest uneven, uncomfortable terrain to beautifully managed, beautifully drawn and implemented landscape. This is variation, this is scope, this is range of civil engineering. Every civil engineer has a right to define itself. I define myself this way. This is one of my first definitions. I know it's not easy, but life says this is a fact. I remember my Libya incident, 93. I joined Libya, one company, half Libyan, half Bharat, joint venture, Libyan one managers. I was on one site, army based site in Sirte. I had to project manage one power station there. Many engineers were there before, gone. I was posted there, and they thought, he may also go back. Okay, I was there, And those people used to tell me below pillows sometimes snakes come there, they bite. Or maybe since this is a forest, complete desert, I did find even in 2 years stay there one dog. Such remote army base and okay, no problem to be stayed there. No toilet, nothing. This early start excavation was, I think, ongoing. That time I took a charge from another engineer, and what I needed was food. Food was available. There was Bharat cook, Punjabi cook, and I had more than 40 or 35 Sikh and others people. They are on site, all residents of site and residents all there. I was also resident of that site. No toilet there on site. No. Libya, early morning, even at 5 o'clock you will find sun or sunlight, sun starts or 4 o'clock. So I was also one of my asked me what to do with this toilet problem. They say no problem. My previous senior said that we use bottle, we'll go in the morning. So there was no option at that time. I'm talking about 1983. So I started doing same. But I was more interested in pushing work rather than thinking of facility. But there was a cabin, residential cabin, auto cabin. It had a seat, but it was not connected, so we could not use that. So one Libyan guy, our manager, came and he asked me his toilet. I told him you have to take bottle and go. Why? He was angry. I recently joined there. He was angry. There's no toilet, I need a toilet. Why are you asking me? His answer was that. Why are you asking me in his language, right? Leishana. You are Mahendras, you are engineer. Your job, you do it. He simply said that. Means I thought he would arrange something, but no, this is your job, you do it, you are civil engineer. Why are you asking me? No need asking. He was a practical person. Later on I discovered that he was a practical guy. So he said, no, you have material. If you don't have material, buy it, or I get it from Tripoli. So we arranged that. So I put some person, there was no plumber even. So we tried it, and some person from our team, means plus or minus, means hook or crook, you can say, we started that toilet with some small septic tank. What I am trying to say, we have to do that job in beginning itself. And there's a site, and we have to start a site, we have to go and see, we have to survey work, and also we have to start, and we have to even remove all scrap from there, all rubbish from there, all garbage from there. So civil engineering, there is a beautiful engineer, you can say in that case. Beautiful means you are going to construct beauty, you are going to construct or produce beauty from scratch or from, you can say, rubbish or rags. You have to do whatever. Your job is very dynamic there. You start from cleaning person, you start from, whatever level you can say. Sometimes you have to be cook also, you have to be office boy, sometimes you have to be a driver, sometimes you have to be a draftsman, sometimes you have to be a planner. Like that, all types of jobs you are required to do. And in particular in that time, no calculator, was not exactly like that. Forget computers, we didn't know even what was computer. And no radio, some people used transistors in those days, because Italy was there, and you can say many other European countries and African countries. I used to listen to Sicily news in those days. Sicily, as a city just opposite to Libya. If you cross Mediterranean, you will find Sicily a part of Italy. So we used to get some film sometimes, on television. Sometimes it used to be by chance you get those. I mean to say, that's life of a civil engineer. No facility, only I could make tea myself, I could do something, noodles, or I could use that cooked food. That facility I had one jeep for company. So how we worked there, I remember today. It's about 83, 84, maybe 36 years back. But those memories are still in the mind as if something is happening now in here now. I'm watching that. Whatever I worked in Libya, I worked in Iraq, I worked, or in Qatar, I worked, or in Abu Dhabi, I worked, or wherever I worked in my lifetime means, I still feel something is happening because we were working on scratches. Scratches. Our food was dust, our food was gas, our food was actual food also, and our food was, break your mind. Break your mind means be busy with your mind. Don't worry about your clothes. Yes, sometimes you get service, sometimes you don't get service. Sometimes you get industrialized projects where you get room service because of company camp. Sometimes you don't get, you have to do yourself. So in Libya, I used to get, I don't know why I'm talking this. I was talking about, this is a part of personal management actually. So I had to cook food myself. So I don't have food of luckily chapatis or rotis called sumons were available, and misi rotis call it, that to buy ready-made food, heat it up, and I used to take some potato, chip out, skin chip out, and boil it with some curd. Used to take that for many months. I used to take that. On site food was available, so that is life of a civil engineer. Sometimes you are in field. You can't expect civil engineer to be aristocratic life. If you think that you are in wrong boat, you should leave that boat, because civil engineering means sacrificing engineer. Engineer that is ready to sacrifice for development of society, for development of infrastructure. Otherwise, civil engineer is no meaning. All other engineers come after civil engineering is done, and they are better placed as far as job is not that struggling. Of course, job is there, but not that struggling as civil engineer does. Many times I have to stay in tents, or sometimes in somewhere you don't know where to stay. For many months I was in some hotel also. So there was no accommodation. Hotel, not very big hotel, guest type hotel, guest room type hotels. You have to eat wherever you want to eat, but you go in the evening and sleep there and come back in the morning and join that. Few months, not all. I still remember all those life of engineering. I can say that that's also a part of engineering management, because this applies to you to one. Remember, if you are engineer or engineering person, and if you are not happy, can you work? Sisters, you have to keep yourself happy if you want to work. Because if you are not happy, you have to do work that time also. And if you are happy, you have to work that way. But when you are happy or you feel happy, you will do work in a better way, in different way. So I can say, based on my experience, that if you are in field of civil engineering, I'm not saying you be in designs or you be in somewhere. Nowadays there are so many locations, so many positions where you need not struggle that lot. For example, planning, designs, you may say quantification. You don't have to struggle that much because you are located in some office somewhere. Even if you are planning, you are located somewhere. Yes, you have to go to site for a number of days, maybe in a month, but you are not always there. But a real civil engineer is that who works on sites and field. I consider that civil engineer is front runner, or you can say warrior of engineering. Just like nowadays we are saying to doctors, they are warriors, they are in front. So front person in civil engineering, really admirable. Of course you may say I'm admiring myself. No, I'm not admiring myself. Admire or don't admire, facts cannot be deleted. If I admire or if I don't admire, it doesn't make a difference, because I am explaining to myself and to my colleagues, my friends, what actually civil engineering is. And if you dream that civil engineering, if your dream is only money, your dream is only package, I think then you are on wrong road. Civil engineering is not your destiny then. Civil engineering is destiny of those who are not behind money, who think differently, very differently. Our salaries are even secondary to mechanical, electrical engineers, and much secondary to administrators like in our country. Civil engineers are not considered anything because I don't know reason for that. I'm not saying that we are everything, it's not that, but we are something, of course. On job, first of all, you have to be very abnormal. Not normal, abnormal I am saying. Abnormal in conduct because you cannot get work done from everyone by being very polite with them, you can't be. Or by being very friendly to them, you can't do. Our work is hard, remember. Work in civil engineering is very hard. Even work of civil engineer is very hard. Forget about workers. We have everything to do from 0 to 100, from A to Z. We have to use mind in full and we have to use our body in full. This is beauty of civil engineering. We have to do a lot of writing and we have to read a lot of writing. That is beauty of civil engineering. You have to be tough. You have to be aggressive. Also, you have to be normal. Because you have a right of aggression on work, not off work. A worker with me, even a guard person, watchman, or a office boy, or even lowest site worker, helper. They are worker on site during work time. After finishing that, they are like me, my friends. Friends means not personal friends. Friends in a way that if I am in charge of site, I must consider myself their elder brother, if not father. And duty of elder brother is always to take care of younger brothers. It's not age-wise, I'm talking responsibility-wise. So as an engineer or as a supervisor or whatever designation you can consider, when you are responsible, you are leading a team of staff and work persons. You are heading them. You are heading them to some destination. They are following you. They shall follow you. So it's your responsibility. When you are expecting them to work for you, they also expect that you do something for them as far as their comforts are concerned, as far as their work welfare is concerned, their safety is concerned, their sometimes emergency is concerned. So you have to be with them to support them. That's very much part of engineering management, which actually engineers do not realize. Facts. Unfortunate it is that we are engineers and we do not understand this point, that they are our team and we are a part of team, as well as engineer is head of team or lead of team, whatever way you can consider. Even if you are first engineer or you are last engineer on site, you have to extract work from others. It's not easy. It's very difficult. Still, work is done by humans on site, humans from whatever country. It's not, I can't say my country alone. And I like it now. Maybe that time I could not understand. I just recall my past and I see that there were so many nationalities with me of all ranks. Of course, there was language problem sometimes. That is a different issue. But humans are human. They used to work. Working was not a problem. They used to work and deliver. What others, everybody used to work. Yes, some nationals have high efficiency, some nationals don't have high efficiency. It depends, but work is work. You know what happens? You have people, you have something in your pocket. When you have something with you, you don't even respect that. You consider them as all. But I never consider it as such. My principle is different. Work is my right. I have to work for myself. I have to work for my organization, and you have to work for me. Me, I mean to say organization, and not me personally. So I had to take work, extract work from my team, work from for company of course, but the responsibility of doing that was mine, or whosoever is there in my place. That's very important point, and we should understand that point rightly. That's why I'm showing all time this quality engineering and project management or project engineering. It's very important actually. If you don't understand that, we release something. You may be whatever degree holder, it's okay. You may be BE, you may be diploma, you may be doctor, you may be master. That's academics. That is academics. That's not practical. It doesn't make anything if you just have that degree. But if you use that degree in field, it's very difficult. You won't be able to use that until you have designs or you have such type of responsibility where you think you have. A mindset is changed actually. Mindset is changed. I understand even if you're a doctor in engineering, doctorate in engineering, you should not change your mindset, because doctor doesn't mean you can solve everything. That's also true. Doctor, master, bachelor, diploma, or whatever, or experienced, or you can say pragmatic person, matured person. Our destiny is competitive work. Competition in work itself, no, not public competition, work competition. When I talk of engineering management, it's not a term that it relates to MBA or something. MBA is different. MBA is not a productive oriented work. It's something means supportive work. But when you call engineering management, here there is no supportive work. Here you are required to deliver it. You are required to deliver it. That's only answer. If you deliver, fine, you are successful. If you don't deliver, you are not suitable for that job. This point must be understood clearly. Maybe the site work or maybe design work, in both cases you have to deliver. In planning you have to deliver, in quantification you have to deliver. And in quality, some different success. So you are not delivering anything in quality, you are doing nothing on your own. You are dependent on the persons working on site. So quality moves in some other direction. Safety is very important. It's a part of engineering management. Because without safety you can't enter site. So simple answer is now. Nowadays, not before. Nowadays. Before, people did not understand safety to that extent. I remember my time of 83, 84, 85, even sometimes in 90s. Safety engineering didn't exist to that extent. It was unknown, means you have to use sometimes, shoes or like that. But it was not mandatory. Here is my photos of those times in 83, 84. You won't find me even wearing, safety helmet. I used to wear cloth cap here, just from protection of sun, not from something else. So safety was missing in those days. I am a person from that time, where safety did not exist. Quality was not separate, but a part of execution work itself. So I am a generation from that point, where RCC just started in those days in a fluent way, though it started somewhere in 30s and 40s, but in practical way, you can say, in public, on projects, in huge response. In those times when I joined civil engineering field, and I still remember working stress method in those days. I used to calculate with that moment of resistance, bending moment, etc. The bending moment is equal to moment of resistance. Use this formula, that formula, and find out what is this and that value, or how much steel we have to use. We used to work out everything like that. Similarly for quantity, Finding, you used to call it estimation actually, not quantity. The quantity is the right word, estimation is not right word. The quantities can't be estimated, quantity have to be computed out. And cost can be identified because cost means rates are not fixed. So I am just trying to communicate to you guys that you are very modern people now. You have all facilities, today's generation. And you are lucky that your computers, you are dynamic, you move fast. Of course, we could not move that fast. But remember, civil engineering is never fast. Civil engineering, if you do it by heart, by soul, it can't move that fast, it moves slow. Now it is fast track because of supports of equipment, supports of many other, we have technologies developed now, many technologies have come up. In those days, everything was not available. I still remember I used to mix concrete on site using our calibrated mixer. Still I remember that. I never got through the remix. We did ourselves gradually, slowly, but what we agreed for, we did that. So engineering management starts from something where there was nothing, and it's now that every subject is there, but people are not responsive. That's only difference is people are not responsive. I took some water there, I'm really thirsty because I think humidity 85% I think humidity here because of last night rain. Its humidity is 85% or 85 or 81%. It's a big one. That's why I put two fans here, one fan in outer room. I kept open this so that window should come and similarly wind should come. So my friends, when I'm talking of engineering management, which is a subject these days, not a term even, it's a full subject. Engineering management is a complete subject. And we have to also understand this point that this management did not come from some author. This management, what I am explaining to you, did not come from some professor or author. This subject is evolution from site. And actually, generally all practical activities sometimes come to education books, but they generate from sites, not from your concepts. I don't think somebody in universities who never works in field can write books as such, but only theory books, textbooks which they are expert of. As far as practical books are concerned, means like engineering management or practice of engineering, what happens in field, only those who have worked in field, they know and they can write that. And such engineering management which covers all such facts from all disciplines of civil engineering, all subjects of civil engineering. It can make a big book regarding engineering management, because engineering management does not mean something where manager is involved. It requires even all activities of workers, what they think, how they work, psychology of workers. That's also a part of engineering management. Psychology of your staff, psychology of your own, psychology of your senior, or how you deal with that. It's interesting that engineering management has come up with. It is still at that time we used to know management. At my time that was only CPM part of bar chart, or some other terms, you can see management. No, that's one part only. Management is you can say engineering field is you start with foundation and there is somewhere sometimes. Management of engineering is everything. You have to manage workers, you have to manage your machines, you have to manage resources, you have to manage materials, you have to manage correspondence, communication, you have to manage material procurement, you have to manage material procurement and machines procurement, you have to manage quality testing, you have to manage quality. Wherever you talk in engineering designs, you have to manage designs, and you manage workshop. I mean to say workers records, workers activities. You have to manage resources activities. You have to manage what's not expected to be. We used to sit in rain for 10-20 minutes, and this activity doesn't harm them, doesn't harm us. Engineering management is very vast. You cannot describe in one go, but in one way I can say whatever we are loving, whatever. So engineering management is one part of life, it's full engineering. It also it goes to mechanical engineering and those, because the humans and resources also there. Even it goes to, I have seen some people, I think they have qualified nearly 4 subjects of engineering if it goes to management. Alright, so management I'm talking of something very different, not what we think is. It's new world. It's not MBA management or some other management. It's completely new. You can say management from very, very ground level. Management from very, very low level. And you have to reach top level. So complete range of management exists in engineering management. Well, I was surprised to see this subject include the syllabus of engineering, but I was happy at least they thought of that. They thought of including management on engineering subjects, though it's not very complete, there's no mathematics in that, there's no formula involved in that, but knowledge is important. If engineer understands that in beginning itself, a student understands what they have to do in field, it's up to them whether they want to continue civil engineering or they want to discontinue that. It's up to them. It doesn't matter if you discontinue, because everybody can't do civil engineering. Civil engineer means, you can say, you have to forget your comforts of life if you want to be civil engineer, because you are away from society. You are not intermingled in society as others do. Yes, forget money. If you want money, don't go to this field. Money-wise, this field is not attractive. But remember, you can get money only if there is civil engineering. If there is no civil engineering, you won't get anything. You may say, I am saying because I am from this field. I am not saying that. I am not saying that. I remember my time. I did not understand what civil and mechanical. I could not understand in my life when I was young, when I was not even degree holder or diploma holder, or not just, I was in secondary schools, and I, like others, did not understand what they have to do in life. So don't think that because, even if I have the respect in my profession, but I was never behind money. I can assure that. Those who can't understand this point of role of engineers, I have written many times, role of site engineers. That role is having many responsibilities. That role is not simply a role, but a role where you can say you have to extract work from others. The extraction of works from others is very big responsibility, and particularly from those who are not very highly educated people. You can't expect construction workers to be very educated. Yes, they are educated by work. They are more educated than your bachelor degree. For example, plumber, steel fixer, welder, mason, carpenter, all these are technicians. I call them technicians. They are skilled artisans. What they can do, I don't do. I can't do that. Can I work as a welder? Yes, welding we learned in our university, but it's not like occupational welder. We know how to do it. That's all. That's purpose of knowing it, not for your occupational practice or vocational practice. But we are taught that so that we can use those people. We should not run away from that. We should not run away from those activities which are black activities, you can say blue activities. Engineer is a blue collar, those workers also blue collar, but it's not to sit in chair and work. Sitting in chair and working is not engineering. You have to sit for something else, for support work, not for original work. When you see, if I work on site, whenever in my life, during my career, if I was on site, I never used to sit there, even for a moment, because if you sit, being leader of their group, they will also copy that sometimes. Okay, if my boss or my engineer can sit, I can also sit for 5 minutes, 10 minutes. What's the problem there? Though they sit, you can't say don't sit, because that's psychological issue, that is mental issue, health issue. You have to give them a pause for free minute. Let us say tea pause or some breakfast pause. You have to give them. That's humanity. After all, they are your family members. Family members in the sense of professional family members. They are workers of whatever class. They are my family members for that work. And if I don't facilitate them, who shall facilitate them? So that is part of engineering management. Means I did not do any obligation on them. It's my duty, my part. If I am using them, they must be cared of. I have to think for their lunch if it's lunchtime, or they think for their breakfast. Means wherever my responsibilities are for their welfare, you have to do that. Sometimes work is on off times, during night, or sometimes they work for continuity, like 48 hours, for 24 hours, 72 hours, for depending on activities. Sometimes concrete goes on for continuation of 2-3 days. There's a concrete program, so you can't expect them to work for 48 hours. Means you have to phase out, you have to stage out, you have to decide how to do that. That's what is engineering management again. Means you have to do planning for that particular activity. It's very important. You cannot simply, there's no guide, no director for you. You are left onto yourself. They only want, your management, your organization only wants results, defect-free results they want, and it is you who is responsible, you and your team. Team means supervision team. They won't ask workers team, they would ask you and your team, engineer and his team, about consequences, about goals achievements, about targets, or why work was not done. They would ask that. They won't listen to your problems, even if you express them problems, but your problems are not their problems, your benefits are their benefits. Problems are always owned by you, and that is where engineering management come in. That's why I always say to my colleagues who are from mechanical, electrical, or from some other engineering field, I say you guys are lucky that you come too late. Means even if electrical guys and mechanical guys, sometimes they are there for meeting purpose. During their activities not moving, they are there for meeting purpose only, means not for involvement on site purpose. Generally it happens. Or sometimes they come just for a few hours, once in 3 months or 1 month. That's not, you can say, involvement. It's just for information exchange, or just to advise something, you do this or that. So when their work starts, building work is always in progress mode, and site people are like settlement. They are routined, they manage themselves, and our team manage them. So that's what happens in engineering management. This is the lowest point of management though, but this is very important management. If you are not an integrated team or unified team, or reliable team, you cannot lead that work, you cannot lead that activity, you cannot lead those activities. That's why engineering management is a very important part. It's not simply that you have to draw some bar chart or you have to draw some CPM or critical path method or program evolution review technique or your part, or you have to do something like that. But your job is over. Bringing that item from market is not our job. It is special job. So my engineering management is understanding is very difficult. I understand is very difficult. We have to manage everything, and that's purpose of management. Means I not simply to say that I drawn this bar chart is CPM. You understand this? No, nobody will understand that. This happened with me when I was in Libya in 1984, I think. Yes, and I was given a job, and somebody asked me, this building is held up for so many years or months. You have to restart it and complete this whatever is left. So I prepared a CPM for that, critical path method. And those days, this many Indians are also there from this BHEL Bhel, and I told them, okay, I made a report of that after visiting site and completing. One was a balance of works that I used some program also from that. So they said, no, we don't want this. They say, we know you understand this. That was CPM program, and CPM program means I had to tell them this is programming. So one of them called me and says, okay, we know you know this, you're a very good engineer as far as programming is concerned. You understand job, but we are not able to understand this. Those are also engineers, but they were not civil engineers, they are mechanical engineers. So I didn't say it was their mistake because they are not acquainted with that. So then I said, okay, means they couldn't understand anything about that, but say, yes, it's okay, you can do like that. So I realized that I wasted my time because these people wanted to that mark. So I said, better to just draw bar charts so that even a layman, you can say, even a site helper can understand if that knows something. Foreman can understand. So bar chart or PERT or CPM or whatever you say it is should be done. I don't understand this people. Well, I was talking on something and I don't know what sort of message people send like this. Well, so engineering management is really, sometimes it seems that it's very easy and sometimes you find that it's too difficult. It's too difficult, You can't anticipate anything. But work is work, you just move. Some people argue something which I don't agree with. They argue not because of engineering, they argue because of degrees. Well, I don't object that, because if you are master or if you are doctor of your profession, you must expect something in that profession. But you don't forget that even if you are a doctor in your field, basically you are an engineer. Then you are a doctor of engineering. Every field has doctor degree, but that doctor degree is not updated one. You should remember. In engineering, it's a reverse move. Knowledge comes from field. Moves to university, and it takes about 5 to 10 years for knowledge to migrate from field to university books. So whatever is taught in university, I'm not against that, but that is not updated one. And that's not detailed one, because in field, whoever are working, they are not professors. They are not lecturers. They are ordinary people, lowest qualified like me. They are ordinary one, who have no time, who have time to work all day, more than 12 hours a day, they work. On average, I am telling you, 10 hours is official time in industry. You can't work 8 hours only, because this is different work. We are producers. We have question of products, means it's not simply unmeasurable work. We have to measure our work. So when you are work 10 to 12 hours a day, 15 hours or 14 hours a day, You think you are left with the time to write something? So that's a justified answer that in general, in field, engineering staff, you can't expect them to write something for you. You can't expect that. It's not possible that they work for you and you enjoy that. That is not possible. I can say that. So what should I say in that case? Well, I should say nothing in that case. Project says itself. We do a lot of things. We do a number of work activities which are not even recorded because it's site. It's not court. It's not office. Everything cannot be recorded. And even if you want to video record, you can't do video recording. How many hours can you record? You may record parts only, some activity part like concrete is ongoing or some special activities ongoing. You can video record for the 5, 10, 20 minutes, half an hour, 2 hour, 1 hour maximum according to requirement, or for your personal records or for company records. You can do that. But it doesn't tell everything. It does not tell everything. So forget complete recording. We can't, we have a procedures management that we have to do this reporting, we have to do that reporting, at this time we have to do this and we have to do that. That's all technically defined. Once we define that, we have to do that. This is called, you can say, kind of method. For every activity we do that, though it may not be in writing, but in practice it is. Those specific information we have on records, and those are always in records, and those are as such, everybody cannot understand that. It's for purpose of record as well for purpose of investigation in future. Means all other activities which are unrecorded, they are only done because you can't record doing on site. You can't record what everybody is doing on site. It's not possible. So we have to understand mechanism from different aspects in this case. Everybody cannot write everything. And moreover, on sites, who are working on sites, who work on sites, those engineers or foremen or like, they can't write what everybody else in other field can write. What a lawyer can write, or what a chartered accountant can write, or what a MA person can write. Those technical people cannot write that because their mostly activities are practical activities, physical activities, not writing activities. As far as writing is required, there's always someone on site specifically for that, and that's called coordinator or coordinating personnel, coordination engineer. On major sites, always they sit not on very small sites. Nobody can afford on small sites coordination like that. So it's the important point, from important viewpoint, what we are and what we should do in the thing of water. I don't know. I'm just trying to explain something which has been included in syllabus. And another aspect is that we manage activities, not total activities, because on no site total activities are done one day. When we talk of activities, on every project there are hundreds of activities, hundreds, not one, not two, but these are not done same day. These are done in months. Let us say we start a site, you start survey, or you take over and you have to mobilize. So that mobilize activity itself is a big one. This mobilization activity contains many activities, serials, many activities, and almost 1 month is required for mobilization. In normal way, maybe 2 months also, depends on what type of site it is. So it has many activities, but those activities are not done in one day. These take time, variation of number of persons, machines, equipment. So you have to establish your site, do your survey work, establish your points, and you have to ensure how you are going to organize these temporary activities, where you have to install your offices, your own offices, your engineers' offices, or subcontractors' offices, where you install your steel fixing yard or steel yard, or where to install your carpentry yard, or where to install your steel yard, something else, or a place where workers may rest for some time, where you have to install your toilets, your sewer line, your containment, where to keep your gate, where to keep your guardhouse, where to keep your something else on the facility, where to put your drinking water and disposal of that water, the sewer lines on site. All that are covered in such activities. You have to get electrical connection from government or some otherwise. You have to install generators. How to install that generator, where to put it, means water supply, this, all that. Water tank, overhead water tank for purpose of site. Where to install your concrete mixer. What circulation is site, how to enter site, now exit site. You want to and fro or you want one way, that point. This is what activity that takes many weeks to do. But it is done. It is done for many years to come. It may take 1 month or 2 months to complete all this for duration of project, which you are going to do for 1.5 years, 2 years, 3 years, depending on that, until you finish that. So such activities also require top management to think about how to do, which place you are selecting for that, how you can do, how far this is from future services. If these items are kept in future services location, then it's wrong, because we have to shift service again. So this is also kind of, you can say, initiation management in engineering. You have to manage all these points. This is nothing to do with the design or something. It's required to be done. Otherwise, you can't move. You can't move essentially for your work. You have to do that. That's why engineering management means this is done on site for every activity. You are going to do concrete work, for example. You are going to do slab, suspended slab. This is a big job. Maybe 500 cubic meter, 1000 cubic meter, 300 cubic meter, depending on contents, depending on quantities. Many activities are there. It's not one day. For that, you have to do columns, you have to do foundations before columns, and then do your formwork, and then you have to, install services in inserts based on approved drawings, and the drawings must be approved. So it takes about, maybe you can say 2 weeks or 3 weeks, maybe 2 weeks, say 2 to 3 weeks for such activities, all activities, so that you are going to pour slab. So this means in one day you cannot do all activities. Your activities are also proportioned and distributed on longer durations. In slab there may be many activities. Formwork is one. Formwork, steel fixing. Steel fixing has 3 activities. Formwork has 2 or 3 activities. And then there is labeling in that. Then column necks are there. Then preparation of columns, construction joints, prepare of beams to come, formworks of beam. Then you can say electrical work. We can say opening out, cutouts of AC, ducts. Like that, there are many more, depending on this. And then after that, many approvals. You have to, yes, supporting system, I forgot to tell you, supporting system is a major one, which may be major one for this supporting system, which can fall also, we can collapse also. And supporting system means, generally they call it centering and shuttering in engineering world, but I say supporting system. For that formwork, the formwork is supported on that system, and formwork then contains reinforcement in that. So how many activities are there? How many times cleaning is done there? How much is done every day is unknown to those who are not working in field, who don't work in field. So what I am saying, every activity is respectable, every activity is important, and when you do, when time comes and you do pouring, say concreting for that slab, which may be 2 days concrete or 3 days concrete, you have to do it continuously. For that you have to arrange differently. You need different teams for everything. That's where you have to anticipate everything. No one can explain to you based on your experience or based on what your team discussion, your concrete crew, your shuttering crew, or your steel crew, or other crews, concrete crews. Most important one, which is a kind of specialized team on site, which is well trained in concreting, even in temperature measurement or some other reasons. They know what you have to do. So what I'm saying is, it's not simply just engineering management. It is engineering detail management, engineering devotional management that works, that you have to work for. What syllabus is, that's fine. Then other than syllabus also there are so many things. When you have experience, you can think a lot, you can write a lot, you can do a lot, but you are not experienced one. You are budding one, you are moving in engineering, you can't do everything, you can't anticipate everything. You can't say that I know this. And those who say that I know this, that person always fails. Can't even start. Because in engineering construction, you have to keep up pace with what's happening. If you discontinue for 2 days, you feel something. What loss there will be on site. I don't know how many people were there, how many they are working. Until you are satisfied that no, it's moving on safe. Then you may do concrete at night, generally at night. So what shall you do? That's the point. So engineering management is very, very different. Means you cannot take different so easily. It's exclusively different. And don't think that only for site people it is. It's for everyone. It's for designs, because design management is also very important. You have to manage designs. Manage designs, manage in a sense that it should be workable, it should be buildable, it should be constructionable. That design, not only design, that design. You may design and say, no, you do it. You may say, no, do it, I have designed this. Don't ask me any change. Then you are not a good designer. Unfortunately, I hate to say. You are not a good designer. Because you are not considering problems on site. You should have, if not full time, you should have some time interact with site guys while you are a designer. If not those site guys, who be there, some other site guys. You should understand, you should anticipate problems on site. If you can do that, you can do better design. Because many aspects which site people know, designs people are not clear about them. If you can, as a designer, suggest method statements, is how this work can be done, best way, or what's intention in your mind. Do you have something specific in your mind? Then you have to write on that time. It should be clear, not simply writing and leaving it. It should be clearly defined what is the intention of your mind is. Otherwise, you are only a drawer, nothing else. You can't understand problems on site. Well, I think explanation has no limit, and everything cannot be given in one day regarding project engineering. It's not possible to give everything in one day. So I'll now move to a small description on site of soil, and then I'll move to I move to soil and also general specifications. Let me move to soil first, just for description. I told yesterday also about that. So let me tell you something more in that. I'll take that talk separately. That is about, it was Qatar section 5. The soil report was there. It is the one. How is not able for the construction section 1, silver capacity 5, QCS 2010, FIDIC comparison of FIDIC and Royal Charter Union contract, Union contract out. Where's that? How will this file is missing? Let me see. What's the reason behind that? Why is missing? Let me see what is missing. Issue on this. This is general and this wage. And resource person, I think it is yes, resource person. Yeah, I talked to you about ASAB geotechnical report yesterday. ASAB geotechnical report was, I don't know why I couldn't get this in mind. Yes, I opened that file now. It's okay. ASAB. Alright, so yesterday I explained to you about Arab Center because I have a report of this. My personal use is this. I got it when I was somewhere, and I didn't put till now on on some website. I'll put it, but just from that, it is a report of this is geotechnical investigation for OGD and AGD front end engineering. It's called field services. This is for Ashab Adabi, and this yesterday I just explained to index of that. So this is a note from Arab Center. This for your information, Arab Center for Engineering Studies is pleased to submit this report of geotechnical investigation for this project. And this was done, this investigation was carried out according to technical services. So contact number is between International Bechtel Company Limited contractor and Arab Centers for Engineering Studies subcontractor, which is effective as a 15 October 2002. So this is subcontractor, and this report presents results of field and laboratory test results, a geotechnical analysis and interpretation of findings, conclusions and recommendations to aid design and construction of foundation. Now we would like to take this opportunity to thank you for your confidence and look forward to be of service to you in near future. And this is Manager Abu Dhabi branch. Now, in this there's an index, and this is a transmitting letter, then table of contents. I explained to this. In this is introduction, purpose of study, scope of work, then project description, site description, prevailing conditions, general geology of area, and what I'm talking is, let us see. First of all, I should tell you that the soil, you may not get confused with that, otherwise it's soil, and soil is this, so that it should be clear to you. What I'm talking is soil. Soil I'm talking from this, just a reference, I'm talking about giving complete one. I don't have a copy of this on website somewhere. You first let me install that one. I'm just giving a brief of this soil investigation, which is much more important than something else. So I written soil for this movie. Soil you can say, which is most reliable, because ultimately your structure transfers all forces to soil, and soil takes those forces. So you can say what is strength of soil. So in this case, I go further. So project description, site descriptions, prevailing conditions, general geology of area, field exploration and testing, then drilling and then excavation of trial pits, soil electrical resistivity test, field to soil test, laboratory testing, surface and subsurface conditions, and after a table of contents continues, and general discussions for choice of suitable foundation, conclusion recommendations, and then all that. Now, let us say, in this report, main attraction is not of text but of annexures, appendix, what it says, location of boreholes and trial pits. That is appendix 1, location of boreholes and trial pits. This means there is a plan on which location is given. Then there is another one, appendix B, is logs of boring and trial pits. And there is legend to logs of boring and trial pits, logs of boring, logs of trial pits, generalized subsurface profiles and field test results. Then field density test results and soil thermal resistivity test results, standard penetration test results, and then laboratory test results, grading curves, Atterberg limits and soil classification, moisture content test results, moisture density relationship and test results, and CBR test results, lab permeability test results, and laboratory thermal resistivity test results, oil and grease test results, and chemical test results for soil and groundwater. Now this is introduction of report, and what the project is. Comprise the following: the activities of given to this laboratory. There's new gas plant, including gas gathering and re-injection facilities, and new NGL recovery units at Assab, and new NGL fractionation train at gas Ruiz, and new condensate storage and shipping at Ruiz, supporting utility and off-site systems at sites and interconnecting pipelines. This geotechnical report covers site area of this, and as Abu Dhabi, findings of geotechnical investigation for other areas will be included in separate reports. Purpose of study, scope of work. Purpose of study is to determine surface and subsurface conditions at proposed project, and physical, mechanical, and chemical properties project, and physical, mechanical, and chemical properties of investigated ground in order to provide structural engineer with sufficient information for design of most suitable and safe foundations. Now, scope of work consists of followings: collecting information and maps, particularly to site such as public services, site plan and land use maps, making inspection visit to site to collect information about present and use. Alright, then we go to making inspection visits to site to collect information about present land use, surface topography, geological features, and surface drainage. Then it is drilling total of 28 boreholes in situ testing and sampling of disturbed and undisturbed samples, and excavation of 3 number trial pits, carrying out 14 number field density tests, carrying out 18 numbers electrical resistivity tests with 0.75, 1.5, 2.253 and 4.5 meter spacing, and carrying out 6 numbers field thermal resistivity tests, carrying out physical, mechanical, thermal, and chemical laboratory tests as follows. Particle size analysis, material passing number 200 sieve, moisture content, Etterbeck's limits, and modified Proctor California weighing ratio, lab thermal resistivity, permeability, chemical analysis, including determination of chlorides, content, sulfate content, pH, calcium carbonate, and magnesium, oil and grease, and petroleum hydrocarbons. In groundwater, chemical analysis including determination of chloride content, sulfate content, pH, and magnesium, oil and grease, and petroleum hydrocarbons. So that performing engineering analysis of field and laboratory findings, developing conclusions and recommendations for design of construction and reporting. Like this, it goes on and on explanations. That's important. I can't speak today everything about this. I'm just giving an information. Means this is available file, and I'll try to upload this file if I could. If I could, I will do it. I can't say today. So, what I say that what is required is important. That point we have to understand. Let me note it is enough for now. Let me put this fan on. Some of my legs now hungry. It's difficult in the morning with 85% humidity in your home. I don't feel comfortable, but what to do? Job is job, work is work to do it. In morning I can do it, otherwise it's difficult to get signals all days. And it's difficult to do in disturbance because in the morning there's no disturbance. I'm free. In daytime, not free. I'm free means you are disturbed by others. But I'm not free from that angle. I keep myself busy with some activity, though it's not professional activity, but I have to be busy. Because sitting idle means you waste your life, and I don't want to waste my life. Soil, you usually call it soil, but it's actually rock. Soil is a result of rock. When this earth was, or the solar system might have been constructed, I am going to that place now. After all, God produced this solar system. We should not forget that. No human in world has capacity to do that. Remember and imagine, there was nothing. Imagine there is no solar system. You are moving in air, in space. You are such a design magnetic person, electron magnetic person, that you can fly in air or space or in vacuum. When we say space means minus pressure, or when we say air means plus pressure. Imagine there is nothing, no solar system. Imagine you are there, you have to construct solar system. Shall you? God asks you, construct solar system. Can you do that? Not getting my point. There is nothing, no solar system. It's blank sky. Sky is there, stars are there. No planet out of these 9 planets, where Earth is also one planet where we have to stay. And you are there, you are representing God, let us say, and your power, God says, is powerful. make one solar system, I want to generate Earth. Who can do that? Certainly you can't, I can't. Because you need those planetary materials. From where shall you bring it? Every planet is very big diameter, globe, and it's still living for centuries have gone, millenniums have gone. Still, it's working safely. Systems on Earth and systems on other planets. Just imagine Sun, 13 lakhs kilometer in diameter. Can you digest it? Can you contain it? 13 lakh or 1.3 million diameter of Sun. Can you digest this? What it is? It's a fact. Earth is only, you can say, 12.5 thousand kilometers in diameter. We can't digest this, we can't understand this. We are talking of soil, and soil relates to Earth. This means every planet must have something like that, like soil or some other thing. I think soil must be there everywhere. But this Earth must be available first. Only then soil can be available. So you produce Earth. You don't know how to produce Earth. You have, because promise, so you are going to do that. Yes, God said earning everything. It's not your time now. So just imagine you have to construct Earth. From where shall you get material? From where? How could God arrange this material for all these planets? All these planets, when there is no material around, how could this material be arranged? It's really imaginary and very, I can't answer this. Where is material? If there had been material, I would have made an Earth, copying this Earth, because we are all copy masters. I could say, okay, we take this Earth and make another Earth. But remember, Earth is 1.5, you can say 15 crores kilometers from Sun. If I want to make an Earth, how? No place here to collect this material. But what God has done then? How could God do that? There is no answer to that. There is no reliable answer to that. Well, I may say scientifically that because God was involved in scientific research of his University of yes, the 3 emissions were stopped. All right, how can I construct Earth? It's only imagination. In imagination I can construct Earth. But God did not imagine, He constructed that. Remember, He might have taken materials from some other planet somewhere else, I don't know, maybe. He might have stored some metal parts, or He might have transformed this material from air, from energy of air. Could be, I can't say. But whatever it is, it's available now. There's no meaning of argument. Earth is available like other planets are available. So this earth we are using for everything. This earth, we call it lithosphere plus aerosphere, this earth. We are using it for our benefit all over the world. God has done what God knows, but we are using that material. And if I have to construct a building, I can't say I can construct in air. We have to use directly under the earth's surface. Soil or rock, one and same thing. Rock is crushed to soil. Dust. And rock is also dust. Rock dust. Or you can say so much. If you use a bracket. Okay. This starts, if you know very well what is earth, what are its structures, what type of surfaces this earth has, how much load it can take, or how it can fail, or how it can cheat us. Knowing all this, acquiring all this knowledge, and just others, yes. We should be thankful to God that we have earth. Don't you think so? Every person on earth must be thankful to God that we are having this earth, or otherwise we won't be in this life. We won't be. We've never been here. This is not only earth. It's wealth for us, it's food for us. It's so much automized now. Earth is so much automatic. You can see so much automatic that it works according to its manifesto. What's Earth manifesto? It works according to that. Then let me put off one window. I think so it's better. I put it so much around 5:28. So let's start 10 for 15 minutes on this, and I'll then start your general specifications. So we have earth and we can use this earth very easily without any problem. Nobody stops from using. If it's yours, though it belongs to none, it belongs to that. It's my part, it's your part, this all story. All story. It's that body's honor. God is honor of this earth. But I am using it for my work because God wants that. If I am going to make a building, it's not because I want, because that power wants, that's why I am using that. Remember, keep this in mind. You can't do anything on your own until that power doesn't want. That is rule of science, rule of nature. You may accept it, may not accept, but fact remains that. You cannot do anything if that God does not want that. Earth, there is no column in that. It's moving freely. No column, no beam, no foundation. And all planets like that. But when I make a small building, I need foundation. I need columns, I need beams, and I have to construct that. Even if I want to make a road, bridge, I have to make that. Columns of bridge. So, this means God has different technology. We don't have. Yes, God has different technologies. God's technology is self-motivation, self-programmed, automatic program, free automatic program. Why did not Earth come down when there is no support? It never came down. And not only Earth, but also all the planets which are in link to Earth. In solar, that's why I call it solar system. In solar system, why these planets are stationary. You would say it's not stationary, there is a movement. Yes, there is a movement. Of course there is a movement. If you understand that, then half of your economical problem is over. Because you understand that movement. Again I tell you, because Earth is not stationary. That's the reason only. Earth is not stationary. Earth moves, and that movement keeps it in balanced position. It moves such fast that it cannot stop even. It moves such fast you can't stop it. And if you stop it, means you will break it. There is no power in human to stop this. There is no human in the world who can stop Earth motion. Earth is moving with high speed, very high speed, and if it stops moving, it will crush. To be very simple. We know it's moving in two speeds, axial speeds and orbital speed. Therefore, it does not need any station to stand, and it never stops for a moment. It keeps on moving and moving as if it's born only for movement, only for motion. Earth is born for motion, and this motion allows residents on Earth, citizens on Earth to get sun every day, to get wind every day, like that. Some different types of statement for people who can't understand what Earth is. Therefore, we need foundations, because our building does not move. It moves with Earth but not on its own. If my building keeps safe while moving, then why do we need foundation? Why do we need something? They are saying porta cabins with some wheels, yeah. But those are not with that much. Means you have to station them somewhere if you want to use those porta cabins. Don't you feel this is miraculous? If you think it's not miraculous. Miraculous in the sense you are getting sun on Earth, sun rays on Earth. There is a power station for Earth. Everybody is using that power. And it's not today. It's far, I don't know how long we are getting that. We are getting that power, and we are getting water itself through rain automatically. Human is not doing anything in that. There's a complete cycle, chemical cycles, environmental cycle that was manufactured by God itself. If I have power, though I don't have, if you have power to do some miracle, do it. Soil is basis of everyone. I only say that because we are living on soil, we are not living in air, we are not living on moon, we are living on earth, and if you have to live on earth, you have to live on soil. Soil means mountain itself. Soil means every continental part. It is only difficult to understand this small point, very difficult to understand. Yes, it is understandable that I have to die one day and mix up in soil, that we understand. From whatever community you are, you understand that. You have to mix up one day with soil. You will be directly graved in, buried in, or you have to go through fire, whatever. Ultimately, your destination is soil. When your ashes are poured into river, these go somewhere and after settle into soil. So the results of both are same. You bury someone, it goes to soil and decompose by chemical composition of soil, and also by burning fire. By fire, you can change those soil in name of timber combustion, and body. Both ultimately convert to bones, and we call them bones is very respectable for people, and they don't know bone is one part, while after having the second part. If I sit on soil, I do not harm myself. I make one house on soil, I do not harm myself. I feel happy that I have done it. I have made a house, and my house is safe. I have pride of that. My house is safe. My building is safe. But I forget this is still moving with earth. So what I want to say, engineering is very confusing itself. You are once saying I am stable, but you are not stable, you are moving. Imagine what happens if one flight comes from space and strikes with earth. What shall happen? It may be flight, or it may be some other piece of nature, natural rock which comes from some other planets and strikes this earth. What shall happen? You imagine that. This earth becomes disbalanced. Maybe it cracked, or it moves somewhere else to some other area. Right? In fact, maybe it moves to 1 billion kilometers, because ultimately space is there, no one to stop it. Or it strikes some other planet and both planets break. That is reason we have to understand that where danger lies. We are just talking engineering on small level. This is big engineering I'm talking, earth. Okay, gentlemen, what I have to say about soil means I will take up this. It's very important part of soil, which civil engineers must understand. In this case, there are many boreholes shown, and boreholes means it's not simply the existing and loading are given, and their existing ground levels are given, and what's available is given in that. So these are that kind of boreholes. These are very important from engineering viewpoint to soil investigation viewpoint. then sampling etc. of these. So I now go on to something which may be useful for me, for you. Pressure of difference, bearing pressure of different areas. Okay. I was trying to find out where is that SVR. Yeah, see that. I was trying to find. Yes, I got something here. Now there is information here regarding this is boring logs information. It is very interesting information. Interests the way that it gives you what is inside of that soil in various stratifications. It gives you that value. It's legion to and this some legend and this legend says so like it indicates a clay, then silt, sand, gravel, cobbles and boulders, peat, fill, crystalline gypsum. This is one line shows. Again I say clay, silt, sand, gravel, cobbles and boulders, peat, fill, crystalline gypsum. Then it says chalk, marl, and calcarenite, calcarenite. Then chert, mudstone, siltstone, sandstone, shale, basalt, phosphate. That gives some sampler type. It's this of a common soil and rock type, means what type of rocks could be there. Then it is sampler type, means tricone, then core barrel, auger, shell by tube, and dry cylinder, dry barrel, dry split spoon, and then it is SPT disturbed, you can say, dry split spoon, SPT disturbed. Now SPT, what is SPT? We must understand SPT, standard penetration test, which has full form of that. This is blows per 30 centimeter. Blows per 30 centimeter. When you put blows like this with certain specified load, per 30 centimeter you have to drive with 30 centimeter. How many blows are required? That's called SPT. Number of blows in standard penetration test required to drive a 5 centimeter diameter, 5 centimeter 2 inch diameter split tube sampler, a distance of 30 centimeter using 63.5 kilogram weight, falling is 776 centimeters. So definition is SPT, blows per 30 centimeter. Every 30 centimeter, how many blows you are going to take? Number of blows in standard penetration test, that is blows per 30 centimeter required to drive 5 centimeter diameter split tube, 5 centimeter, only 2 inches diameter split tube sampler, a distance of 30 centimeters, used 6 and 3. So again I say, it's very important definition. Number of blows in standard penetration test required to drive 5 centimeter is diameter split tube sampler, a distance of 30 centimeter, using 63 and half percent price. So it's that in 63, it is 63 and half kilogram weight falling 76 centimeters. 63, so here's the weight. It falls from that height in the where on which you have to strike it. It is 76 centimeters down. 76 centimeters down. You can say 2.5 feet. Yes. So 5 centimeter diameter, and this is 5 centimeter diameter split tube, and 60 centimeter down is go 30 minutes below 60. Alright, now this was definition of SP, which is very important none. So again I am saying a weight of 63 and a half, 63 kilogram and a half, to drive down 76 centimeter on 5 centimeter sampler. And how many blows are there per this 30 centimeter down? When this goes 30 centimeter down in this 76 centimeter height blow, 30 centimeter penetration is called SPT. You got my point? Means this is here, I am putting like this here. This is 76 centimeter, 63 kilogram and a half. This weight comes 76 centimeter, and I have to see this goes down. This goes down, and in 60 and in 30 centimeter movement, how many blows are there? That's point here. If you got right, if you don't got it, consider here it is, it is here. There's a weight here. This is a, I put it down. Here's that 76 height, and this is 63.5, like this, It goes on this, goes on this, goes on this, goes on this. It goes down by 30 centimeter, and we have to count that one. That's 30 centimeter. How many blows are there? That's called SPT, standard penetration test. So in this there are SPTs, which is given for fine grained soil and for coarse grained soil separately is given. It's given if SPT blows per 30 centimeter is only 0 to 2, it's very soft soil. If it is 0 to 2, which says SPT number of blows is 2 to 4, it's soft soil, and if it's 4 to 6, it is firm soil. Come on now. So 0 to 2 when SPT is very soft soil, 2 to 4 is soft soil, 4 to 8 is firm, 8 to 15 is stiff, 15 to 30 is very stiff, and greater than 30 is hard. Greater than 30 is hard, this is fine grained soil. And coarse grained soil 0 to 4 is very loose. So just maybe 0 to 4 and 4 to 10 is loose, and you can say 10 to 30 is medium dense, and 30 to 50 it is dense, and greater than 50 is very dense. So this is range of SPT and not of something else. We will see that. And now what happens, notice there percentage of length of core recovered, percentage of length of core recovered in each run to total length of Okay, then we move down to further percentage of length of core recovered in each run to total length of core run. That is called recovery. Recovery of core. We are taking core from this test of this experimental SPT to finding that. I will say we continue to take out that circular cylindrical cores from that. So what percentage of length core recovered in each run to total length of core run? That's our point. So we have taken one bore, we have taken out soil from that. We measure that total boring is this, and how many pieces are there which can be measured, and if you divide length of those pieces and total length, you get recovery. Means what? How much is recovery? That's important. Then point load strength and unconfined compressive strength, that will say later on, and it is again in rock quality in different forms given. This is 0 to 25. This is rock quality designation in RQD, and that is so this is recovery. Now we go to recovery. We have seen recovery, then we go to rock quality. In rock quality we can say 0 to 25 is very poor, 25 to 50 is poor, 50 to 70 is fair, 70 to 90 is good, 90 to 100 is excellent. This is for rock quality in various kinds of soils, and we will see this later on. Now we have to see appendixes also. What's there? Let me see. This is appendix with log of boring, Arab Center for Study. So for every bore, they will give you some sketch, some graph. You have to understand that. For everything they give that. Then we say, if I have to go this, I'm just trying to give you a brief of this so that we can understand what we have to do. Now in this there are so many notations in these reports of bore log. It says ST, that is sampler type, ST. We'll see all this. ST is sampler type, and TCR, total core recovery, SCR is solid core recovery, and total core recovery. Then an RQD, rock quality designation, and that There is another one is SCR sand core recovery, then RQD rock quality designation, SPT sand penetration test, UCS unconfined compressive strength, DD dry density, RL reduced level. These are notations in that, and there are further diagrams: standard penetration, trichon bit, and undisturbed sample, rock curing, water table, auger. Then in this also given remarks coordinations are plant coordinations and levels are relative to New Abu Dhabi or whatever it is. This is noting is there for that. So all these are separately given. We will take that later on. So what I am to say is, I'll pull it down. And then there is some other, the soil electrical resistivity is there in one table. Soil resistivity, yes. There's a in situ density test result. It's about ASTMD 1556. This is test number, boring number, or can say borehole number, test depth, moisture content, bulk density, dry density, like that there is. And this soil electrical resistivity test results, soil electrical resistivity, all these are there. I actually close it so that we can take it tomorrow. So what I do, I now close this file because purpose of this file is to start only when we actually deal with this. I'm just giving you formal information about this. I'll open now. So this file I have closed. I'll open now your file of I open this file. FIDIC. FIDIC. FIDIC, we move to FIDIC now. And before that, I should wait a minute, fake something, sorry. FIDIC is there, but also there is another one. I confuse, and it's a general of that. General. So let us take first general and then FIDIC. Otherwise, sequence will break. I'm sorry for FIDIC, and I open FIDIC, but I will close it now. I'll before that open. This is section 1 general. So let it open and see how it works. So we talked in general, and we was at page some 175 somewhere. Then it is now. Yeah, gone. I think my mistake. It's not that. I will go to 35 thing. Program of works. I was somewhere subcontract, I remember. It's not that far, I think it's not that far. Some meters we had done, yes. Some meters we did. Where were we? Subcontractors, I remember that subcontractors. Okay, I'll get somewhere nearby. Submittals. Yes, submittals we had done. Now survey and layout details is page 47. Survey and layout details, this is what we are going to do, and then method statements. Method statements. After submittals, the contact this. Okay, let's start. Mr. Chaudhary Raju, good morning. Cannot see you now. Say thank you very much. And now so we move to survey and layout details. Setting out of works. Setting out of works. Submittals associated with setting out of works shall comply with relevant provisions of Part 13 of this section. Setting out, I'm talking about Section 1 General of QCS. It is very general because we completed concrete, now we are working on this. Okay. What I say submittals we are done. Method statements now. Submittals for survey and we are done. Method statements general. There is a legal requirement for contractor. Legal requirements, mandatory it is. This means there is a legal requirement for contractor, including employers and self-employed, to develop and submit for comments to engineer suitable and sufficient written method of work, commonly known as method statement for his work activities. Method of work, commonly known as method statement for activities, for work activities. So method statement is a written statement here says in the suitable. Above is also to be completed as and when required or instructed by engineer for whatever identified work, activity and submitted per time scales are to be specified by engineer. So this is definition of this. We read it again because it's not easy for everybody to understand in one statement. It is legal requirement for contractors, including employers and self-employed, to develop and submit for comments to engineer suitable and sufficient written method of work, commonly known as method statement for work activities. This also to be completed as and when instructed by engineer for whatever identified work activity and submitted for timelines to be specified by engineer. Legal requirement is in regulatory document section 11 part 1, in particular section 117 risk assessments and method statement. So section 11 we have to find out. We'll see later on. Now I don't have a copy of that. I'll see if I can get that. Section 1, part 1, particular section 1. I think section 11 maybe I have. Well, we'll see. Section 11, part 1. Section 11, not part 11. Okay, section 11. Well, legal requirement is regulatory document. Section 11, part 1, in particular section 117, risk assessments and method statements. Now, guidance on compliance with requirement in regards to method statement is found in section 11, part 2, in particular section 2.4, risk assessment and method statements. So we will see section 11 later on. I am sure I don't have this yet now. I'll try to find out if I have this from script or somewhere else. Now, application and invoices for completed works. Applications and invoices for completed works. Now, this is general. Applications and invoices for completed works shall be submitted in accordance with conditions of contract. Applications and invoices for completed works shall be submitted in accordance with conditions of contract. Measurement of quantities. Contractor shall provide engineer with all assistance as and when required for measurement of quantities. Contractor shall be responsible for preparation and duplication of all calculations across cross sections and other drawings related to quantities in interim payments. These shall be submitted in draft to engineer in sufficient time to enable him to check and agree them before submission for payments. Well, this is just the provisions, not necessary for lump sums. Now we go there for building demolition. This is section 1, of course, part 8. So building demolitions, this is a chapter of building demolition. What is actually demolition and why it is, that we have to understand that. Demolition. Building demolition. See, general, it says scope, references, definitions, records, matters arising, safety, use of explosives, spatial investigations. These are points in general, or here I say scope, references, definitions, records, material arising, safety, use of explosives, special investigations, and then A2 is building demolition, in which this is scope, reference, general requirements and standard demolition, utility services, spatial demolitions, selective demolitions, temporary work, and then hazardous materials is scope, relevant authorities, method statement, special precautions and disposal. Then now we go to building demolition general. Let's start with general, the scope. This section specifies requirements for demolition work, disposal of materials. This section specifies requirements for demolition work, disposal of materials arising from demolition work, and procedures for dealing with hazardous materials encountered during demolition work. Means, for the scope of this, requirements for demolition work, disposal of materials arising from different demolitions works, and procedures for dealing with hazardous materials encountered during demolition works. Related sections are general, section 1, roadwork, section 6, section 12 is earthwork related to buildings, and section 28 is landscaping. References. Following standards are referred to in this section: BS 5607, safe use of explosive in construction industry, means 5607, which relates to safe use of explosives, and BS 6657, that is a guide to prevention of inadvertent initiation of electro explosive devices by any frequent condition. Okay, now demolitions. Demolition. What do you understand demolition? First, we have to see that one, though it's not given here. Simply written, which is not right one. Work done. Their definition of demolition begins work done to dismantle or take apart and remove all existing building or facility. This is given. Work done to dismantle or take apart and remove an existing building or facility. Then hazardous material is defined general term to encompass certain and all materials which have been contaminated by substances which are dangerous or potentially dangerous to public. It's inclusive of materials. It's inclusive of materials which, if not properly contained, would continue to spread and contaminate soil, groundwater, or becomes airborne. Alright, so work done, let us say hazardous materials, I repeat, this is an important point, hazardous materials. Hazardous materials, explosives, you may say that, hazardous materials, that is general term to encompass any all materials which have been contaminated by substances which are dangerous or potentially dangerous to public. It's inclusive of materials which, if not properly contained, could continue to spread and contaminate soil, groundwater, or become airborne. Hazardous materials. Then this is contaminated materials, we can say, substances we can say, which are dangerous or which are potentially dangerous to public and which could spoil your soil, spoil your groundwater, or become airborne. That can also be a problem. Then materials arising. So hazardous material definition is also to be repeated. It's important for those who are going to study in safety, etc. So, materials arising. Parts or portions of building materials or accessories which are removed or salvaged once demolition process begins. This is material arising in salvage materials. Because of demolition, we have to save some material. It breaks, has some legs. Okay, it says materials arising any parts or portion of building, any part or portion of building materials or accessories which are removed or salvaged once demolition process begins. Then method statement. So this is a material arising method statement. Define method or process to be followed for demolition of a specific project. There is selective demolition. Selective demolition, typically refers to demolition work done to only parts of buildings of a facility for retrofit or renovation type work. So materializing is method statements. Method statements define method or procedure to be followed for demolition of a specific project. Then selective demolition. Okay, selective demolition typically refers for demolition works done. Yeah, alright. Selective demolition. You know, typically refers to demolition work done to only parts of buildings or facilities for retrofit for renovation type work. Okay, selective demolition typically refers to demolition work done to only parts of buildings or facilities for retrofit or for renovation purpose. Unsafe, unstable. Reference to this section. This is interrupted, interpreted to mean a building or structure or condition which is dangerous to safety of public, that is unsafe building. Now what are the essential you need? That's the important point. Now we are going to Demolition is really very, very troublesome because you have to break something. It's not construction, but this is very difficult. You have to take safety measures everywhere. That's why it's unsafe. In reference to this section, this is interpreted to mean a building or shed structures or condition which is dangerous to speak of safety of building. Yeah, surprising. It says records of documentation. All available plans of structure to be demolished are to be examined, and where nature of construction is uncertain, a special investigation is to be carried out as agreed with the engineer. Yes, demolition records. Available plans of structure to be demolished are to be examined, and where nature of construction is uncertain, a special investigation is to be conducted or carried out as agreed with the engineer. Adjacent buildings or structures shall be inspected, and their existing interior and exterior conditions shall be documented. Can you read? Or otherwise. Adjacent building or structure will be inspected, and their existing interior and exterior conditions shall be documented prior to and after demolition in writing or photographed or both. Materials arising. General requirement. Materials arising we are talking. Let me put, I can just go over better. All materials arising from demolitions are to become property of contractor, unless otherwise specified in project documentation. Materials arising shall be cleared from site as work proceeds in an approved manner. Materials arising from demolitions and alterations are not to be burnt on site. Removal operations for materials arising should be conducted with least interference to public and not be started until approved by engineer. Removal operations. Engineer has right to reject off site disposal plans if disposal would leave an unsightly condemn anywhere. The unsightly condition anywhere. This is an important point. You can read it again. All matters arising from demolitions are to become property of contractor unless otherwise specified in project documentation. Materials arising shall be cleared off from site as work proceeds in an approved manner. Materials arising from demolitions and alterations are not to be burnt on site. Removal operations for materials arising should be conducted with least interference, least interference to public and not be started until uh, all right, now come to no. Metals rising shall be cleared from site as work proceeds in an approved manner. Metals rising from demolition and alterations are not to be burnt on site. Removal operations for material arising should be conducted with least interference to public and not be started unit approved by engineer. After that, removal operations for materials rising should be conducted with least interference to public and not be started until approval is given. An engineer has right to reject of site disposal plans if disposal would have an unsightly condition anywhere. Safety requirement. What safety are seen as? Safety during demolition. That's a very important point because of safety. It can cause harm to other buildings, so we have to be careful about that. Contract is to provide safeguards including warning signs. Contract is to provide safeguards including warning signs, barricades, temporary fences required for protection of public and site personnel during demolition and removal operations. Safeguards are to be maintained until demolition and removal operations are complete. Within populated or trafficked areas and when adjustment to other structures, contract is to provide enclosed rubbish chutes from each floor to carry debris into disposal trucks or skips. Overhead bridges of tight board of prefabricated metal construction to be provided at rubbish chute to protect persons and property from falling debris. Contractors shall conduct operations in a manner that minimizes spread of flying particles and dust. Now, rubbish and debris shall be sprinkled water to keep dust to minimum. Contractor shall conduct his operations in a manner that minimizes spread of flying particles and dust. Rubbish and debris shall be sprinkled with water to keep dust to minimum. In addition, following safety rules shall be observed in performance of work. No wall or part of wall shall be permitted to fall outwardly from structures. If building is to be demolished story by story, At least one stairway in each structure shall be maintained in maintained in usable condition to highest remaining floor. Stairways are to be kept free of the obstructions and debris until the level of structure has been removed. Whenever a whenever a cutting touches or other equipment, so wherever is cutting torch or other equipment that might cause a fire, so it says whenever cutting torch or other equipment that might cause a fire is used, provide and maintain fire extinguishers nearby ready for immediate use. All possible users are to be instructed to use fire extinguishers. Then hydrants. No. Hydrants are to be accessible at all times. No debris to be permitted, no accumulate within a radius of 4 meters of hydration. Contractor will all time comply with requirements of Civil Defence Department. Contractor shall comply with Civil Defence Department in case of structures that are to be partly demolished. Condition of those parts of structure that are to be retained shall be checked for safety and stability before any demolition work begins. Similarly, conditions to adopt condition of adjoining properties which may be affected by demolition shall be checked for safety alert, for safety and stability. And any question? Ah, very boring. Independently supported, what I say, independently supported platforms are to be provided to avoid working from. Independently supported platforms are to be provided to avoid working from that part of structure being demolished. Isolated walls shall not be left unshored. Isolated walls should not be left unshored unless they are structurally stable against wind and other forces likely to affect them. Now, use of explosives. Use of explosives. This is 635. Okay, let me put off light, I think. Let's see, put off light, those, let me see. Uh, when use of explosive is necessary for carrying out work, demolition work, contractor is to exercise most care not to endanger life or property. When use of explosives is necessary, though it's not necessary, if it is necessary for carrying out works, contractor is to exercise utmost care not to endanger life or property. Contractor shall be responsible for all damage resulting from use of explosives. All explosives are to be stored in secure manner in compliance with all requirements of police, civil defense department and manufacturing of explosives. All such storage places are to be clearly marked dangerous explosives in English and Arabic and shall be in care of a competent watchman. It's Arabic because this is Arab word. Explosives will not be stored closer than 300 meters from any road, building, camping area or place or of human occupation. So 300 millimeter, meters is limit here. Procedure. 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 Contractor is to notify public utility department having structures in proximity to site of his intention to use explosives. Such notice shall be given sufficiently in advance in order to enable said authorities to take such steps as they may deem necessary to protect their property from damage. Written consent of engineer is to be obtained for each proposal of contractor to use explosives. Where blasting is proposed adjacent to building or other structures existing or under construction, contractor will satisfy engineer that safe values of vibrational amplitude and peak particles velocity will not be exceeded. Contractor is to comply with provisions of BS 6657 in respect of use of electrical detonators. Electrical detonators to invasion of static and mobile radio transmitters. So, I mean stuff, so they are just counting Contractors to comply with provisions of BS 6657 in respect of use of electrical detonators in vicinity of static and mobile radio transmitters, including normal radio and television broadcasting stations and radar units associated with aircraft movement. Then handling transport and use of explosives, handling transport and use of explosives shall be in accordance with relevant provisions of BS 5607. Explosives are to be used in quantities and manner recommended by manufacturers. Now special investigations now. Special investigations general description. Contractor is to ascertain from responsible authority whether any means or services need be redirected or cut off. Contractors to ascertain from responsible authority whether means or services need be redirected or cut off. Contractor shall conform to any procedures prescribed by relevant authority and engineer. Now, notwithstanding any information supplied by engineer, contractor is to take all necessary steps. Alright, now special investigation general description. Contractor is to ascertain from his responsible authority whether any means or services need to be redirected or cut off. Contractor shall conform to any procedures prescribed by relevant authority and engineer. Notwithstanding any information supplied by engineer, contractor is to take all necessary steps to establish presence of any stressed component supporting walls and like in structures to be demolished, where special circumstances such as unknown soil conditions exist. So, notwithstanding any information supplied by engineer, contractor is to take all necessary steps to establish presence of stressed components surprising. Now, presence of any stress components supporting walls and like in structures to be demolished, where special circumstances such as unknown soil conditions exist, which could reveal hazardous material, or where structural components of building support systems are unknown, additional investigations as necessary shall be performed. Our cost of such investigation shall be borne by contractors unless otherwise stated in project documentation. Now, building demolition. Building demolition part specifies procedures and requirements for demolition and removal of buildings, structures and related services utilities. Scope of demolition or renovation work is specified in three categories of demolition. Category number 1, standard demolition, typical type demolition work. Then 2, spatial demolition, demolition of partially collapsed or unsafe structures. And selective demolition, demolition required for alteration or expansion type work. Related parts and sections in this are Part 1 General, Part 3 Hazardous Materials, Section 1 is General, Section 2 is Earthwork related to buildings and contain earthwork. So we see what to do in this building demolition now. So we can say standard demolition, spatial demolition, selective demolition. Related parts are general, part 3 hazardous materials, section 1 general, section 12 earthwork related to buildings, section 28 landscaping. References are following standard references: BS5607, safe use of explosives in construction industry, and section 01 part 8. Okay, then what is the references? This is one reference only, 5607. Now general requirements. So general requirements, now we'll go to general requirements. Let's see what it says. Unless otherwise indicated in project documents directed by engineer, the contract is to complete. Let me see. We should continue to separate one because we have to study for FIDIC also. Just 2-3 minutes more. General requirements. Unless otherwise indicated in project documentation or directed by engineer, contract is to complete demolition and removal of buildings and structures together with all foundations, retaining walls, piers, partitions, and equipped columns, and associated services, utilities. Okay. Just about 1 hour more. So unless otherwise indicated project documentation backed by engineer, contracts to complete demolition, removal of buildings and structures together with all foundations and retaining walls, piers, partitions, columns, associated services, utilities. Demolitions to be carried out in planned and safe sequence, generally in reverse order of erection, reducing shell of building in small lifts. Contractor is responsible for removal and disposal of all debris resulting from demolition work. Upon handover of site to contractor, contractor is to take over all responsibilities of buildings to be demolished. Now, contractor is to inspect each building he is to remove and determine for himself work involved and equipment and materials required for specified demolition work. Contract shall, at its own expense, make good damages done to others' properties during demolition works. Standard demolition. So these are definitions of that. I think we should move to leave it now. I think we should go to FIDIC for this page 53. Let us say we do to FIDIC now. Only small time is left, something FIDIC. So I close this file here. So we are here with FIDIC and now FIDIC, because FIDIC, I'll take something here, something there, so that my mind also keeps busy rather than sitting on one and losing sleep. Let's now continue on FIDIC 2000. We left yesterday at some point. Let me see which point was that. It may be 170 page, I think, 170 page or 5 page, I don't exactly remember. We are at subcontractor, I remember. We are subcontractor, we are at so milestones of this and subcontractors. So class 5 subcontractor, this page 179 of 225 is subcontractors in red book. So let me see what is. Before that, I like to close my window because there's no wind when it is coming in. I'll put light also off. So let us start this now and see how to do this. Okay. Let's put up both. Subcontractors, this is subclass 5.1. It may be appropriate or desirable, taking account of circumstances and locality of project, to encourage contractor to employ local contractors in execution of work. Example: contract shall give reasonable opportunity to contractors from country to tender for subcontractors for works, and shall use reasonable endeavours to employ such contractors as subcontractors. If no consent by engineer to subcontractors is required, last 3 paragraphs of this subclause may be deleted. If less consent by engineer to subcontract is preferable, subclause may be amended. What to do? Now, after subparagraphs 2 of subclause 5.1, add or clauses is subcontractor where value of his or subcontract is less than 1% of accepted contract amount. If engineer's consent is required to suppliers of certain materials, this subclause may be amended. Example: at end of this 3rd paragraph of subclause 5.1, however, it is written, however, engineer's prior consent shall be required for supplies of following materials. You write materials here. Insert details, for example, specific materials or prefabricated items of materials. If employer requires that all contractors, subcontractors should provide for assignment of subcontract to employers in event that subclause 15.2 termination for contractor's default applies, following amendment shall need be made to subclause, that is insert at end of last paragraph of subclause 5.1. What's that? All subcontracts relating to works, all subcontracts related to works shall include provisions which entitle employer to require subcontract to be assigned to employer under subparagraph A of subclause 15.2.3 after termination. If employer requires that contractor assigns benefits of relevant subcontract in event that subcontractor's obligations continue after expiry of DNP, and that is defects notification period, DNP, relating to that subcontractor's work, following amendment shall need be made to this subclause. Now example is insert at end of last paragraph of subclause 5.1. If a subcontractor's obligations to contractor extend beyond expiry date of DNP, which is applicable to subcontractor's work, and if contractor receives an instruction from engineer to do so not less than 7 days before this expiry date, contractor shall assign benefits of such obligations to employer unless otherwise stated in assignment. Contractor shall have no liability to employer for work carried out by subcontractor after assignment takes effect. Nominated subcontractor, subclause 5.2. Nominated subcontract. Normally, contractor will you 3 hours 13 minutes. Okay. Normally, contractor shall elect or select an employee subcontractor subject to whatever constraints stated in contract, but this subclause provides for situation where employer may wish to select a particular subcontractor or subcontractors to be employed by contractor in execution of works. If this is the case, it is recommended that employer names particular subcontractors in specifications so that tenders are aware of this requirement before submitting their tenders. Although this subclause also makes provisions for engineer to instruct contractor to employ a subcontractor or subcontractors selected by employer after contract award, it should be noted that once contractor has employed a subcontractor who has been nominated by employer, second paragraph of subcontract clause 5.1, subcontractor applies, and subparagraph B of subclause 13.4, provisional sums should provide payment to contractor for works or services to be purchased by contractor from a nominated subcontractor. Then, wait a minute. मानेंगे नहीं ये लोग भाई, फालतू से लिखे जा रहे हैं, हम तो लिखे जा रहे हैं, कहीं कर रहे हैं दूसरे को. All right. So nominated subcontractor is this. Now what I say about this? In this, if employer anticipates that subcontract is to be instructed under subclass 13.3 variation procedure but is not to be nominated subcontractor, this subclass should be amended describing particular circumstances. In this case, it is recommended that employer names particular subcontractors in specifications so that tenderers are aware of this requirement before submitting their tenders. And once contractor has employed a subcontractor who has been nominated by employer, second paragraph subclause about this, and subparagraph B of subclass 13.4 provisional sums should provide the payment to contractor for works or services to be purchased by contractor from nominated subcontractor. Well, now go to clause 6, staff and workers, so staff and labor. Staff and labor. Staff and labor. Staff and labor, one important point. This is clause 6, subclause 6.3. Staff and labor. It is the percentage of this battery is now 1 hour 40 minutes. Okay. Recruitment of persons. It may be necessary to review and revise this subclass or delete it in its entirety. If relevant labor laws applicable to contractors' personnel and or employers' personnel do not permit any restriction on right of any worker to seek other positions. Subclass 6.6 facilities for staff and labor. If employer plans to make any facilities of work and or accommodation, for example, offices accommodation available for contractors' occupation and use, employers' obligations to do so, and details of such facilities and or accommodation should be stated. Okay. Facilities for staff and labor. We're talking of this, we just had a break there due to some reason, because these are very ending clauses after that. Facilities for staff and labor. If employer plans to make certain facilities and or accommodation, for example, office accommodation available for contractors' occupation and or use, employer's obligation to do so and details of such facilities and or accommodation should be stated in specification. See also guidance under clause 17, care of works and indemnities below for suggested additional subclause in respect of responsibility for care of such facilities and or accommodation. Contractor superintendence, subclause 6.8. Contractor superintendence, that is contract's highest staff. If it is permissible that contractor superintending staff are not all fluent in language for communication defined in subclause 14 law and language, then consideration should be given to amending this clause. You should add that, or if not, contractor shall make competent interpretation available during all working hours in a number sufficient for those persons to properly perform their superintendent's duties. And if necessary, to stipulate that contractor superintending staff shall be fluent in a particular language, following sentence should be added. Insert at end of subclause 6.8. A reasonable proportion of contractor superintending staff shall have a working knowledge of this language, or contractor shall make interpreters available on site during all working hours in number deemed sufficient by engineer. Then key personnel. It is permissible that all key personnel are not fluent in language for communications defined in subclause 1.4 law and language. Then consideration should be given to amending the subclause. Insert at end of last paragraph of subclause 6.12. If any of the personnel are not fluent in this language, the contractor shall make competent interpreters available during working hours sufficient for that person to properly perform his or her duties under contract. Now, additional subclauses. It may be necessary, appropriate, and or desirable to include additional subclauses to take account of circumstances and locality of site. Example: subclause for foreign personnel. Subclause for foreign personnel. Contractor may bring into country any foreign personnel who are necessary for execution of work to extent allowed by applicable law. Contractors shall ensure that these personnel are provided with required residence, visas, and work permits. Employer shall, if required by contractor, use all reasonable endeavors in a timely and expeditious manner to assist contractor in obtaining whatever local, state, national, or government permission required by for bringing in contractor's personnel. Contractors shall be responsible for return of this personnel to place where they were recruited for, to their domicile. In event of his death in country of whatever any of these personnel or members of their families, contractor shall similarly be responsible for making appropriate arrangement for their return or burial. Return or burial. Example of subclause for supply of foodstuff. Contractor shall arrange for provision of a sufficient supply of suitable food as may be stated in the specification at reasonable price for contractor's personnel for purpose of or in connection with contract. Example, subclass for supply of water. Contractor shall, having regard to local conditions, provide on site an adequate supply of drinking and other water for use of contractors' personnel. Example: subclass for measures against insect and pest nuisance. Contractor shall at all times take necessary precautions to protect contractors' personnel employed on site from insect and pest nuisance and to reduce danger to their health. Contractors shall comply with all regulations of local health authorities including use of appropriate insecticides. Example: subclass for alcoholic liquor or drugs. Contractor shall not, other than in accordance with laws of country, import, sell, give, barter, or otherwise dispose of any alcoholic liquor or drugs, or permit or allow importing sale, gift, barter, or disposal thereto by contractors personnel. Example: subclass for arms and ammunition. Contractor shall not give, barter, or otherwise dispose of any person any arms or ammunition of whatever kind, or allow contractors personnel to do so. Example: subclass for festivals and religious customs. Contractors shall respect countries' recognized festivals, days of rest, and religious or other customs. Example: subcontractor for funeral arrangements. Contractors shall be responsible to extent required by local regulations for making any funeral arrangements for any of contractors or local employees who may die while engaged upon works. Example: subclass for forced labor. Contractors shall not employ forced labor which consists of whatever work or service not voluntarily performed that is exacted from an individual under threat of force or penalty, and includes any kind of involuntary or compulsory labor such as indentured labor, bonded labor, or similar labor contracting arrangements. Indentured labor. Example: subclass for child labor. Contractors shall not employ children, any natural persons under age of 18 years in a manner that is economically exploitative or is likely to be hazardous or to interfere with child's education or be harmful to child's health or physical, mental, spiritual, moral, or social development. Where relevant, labor laws of country have provisions for employment of minors, contractors shall follow those laws applicable to contractor. Examples of contract for employment: records of workers. I think I should take care of this battery now. Maybe it's gone. Sit, let me put the battery on. Difficult time. Otherwise, I'll sit down and go. Put this on. Okay. Battery is on. It's on. Okay. This battery is on. Okay. This will get battery. Alright. Example of subclass for employment: records of workers. Contractor Contractors shall keep complete and accurate records of employment of labor at site. Records shall include names, ages, genders, hours worked, and wages paid to all workers. These records shall be summarized on a monthly basis and submitted to engineer. These records shall be included in details will be submitted by contractor under subclause 610. Now, example subclause for workers organizations. In countries where relevant labor laws recognize workers, relevant labor laws recognize workers, rights to form and to join workers' organizations of their choosing without interference and to bargain collectively. Contractors shall comply with such laws. Where relevant labor laws substantially restrict workers' organizations, contractors shall enable alternative means for contractors' personnel to express their grievances and protect their rights regarding working conditions and terms of employment in either case described above, and where relevant labor laws are silent, contractors shall not discourage contractors' personnel from forming or joining workers' organizations of their choosing or from bargaining collectively, and shall not discriminate or retaliate against contractors' personnel who participate or seek to participate in such organizations and bargain collectively. Contractors shall engage with such workers' representatives. Workers' organizations are expected to fairly represent workers in workforce. Example, subclass for non-discrimination and equal opportunity. Non-discrimination and equal opportunity. Alright, so we are talking of example subclass for non-discrimination and equal opportunity. Contractors shall not make employment decisions on basis of personal characteristics unrelated to inherent job requirements. Contractors shall base employment relationship on principle of equal opportunity and fair treatment, and shall not discriminate with respect to aspects of employment relationship, including recruitment and hiring, compensation, including wages and benefits, working conditions and terms of employment, access to training, promotion, termination of employment or retirement, and discipline. In countries where relevant labor laws provide for non-discrimination in employment, contractors shall comply with such laws. When relevant labor laws are silent on non-discrimination in employment, contractors shall meet requirements under subclause special measures of protection or assistance to remedy past discrimination or selection for a particular job based on inherent requirements of job shall not be deemed discrimination. Clause 7, subclause 7-7, and plant materials and workmanship. Okay, then we say clause 7, that is plant materials and workmanship, that is ownership of plant and materials. Well, 7:21, what time we have? 3:36, so we have enough time. Plant materials and workmanship, ownership of plant materials, clause 7.7, clause 7. If contract is to provide high value items of plants and materials under contract, consideration may be given to amending subclause. Example, insert at end of subclause 7.7, no plant and or materials that is property of employer shall be removed from site if it becomes necessary to remove any item. If it becomes necessary to remove some item from site for purposes of repair, contractor shall give a notice with reasons to engineer requesting consent to remove defective or damaged item off site. This notice shall clearly identify an item of defective or damaged plant and shall give details of defect or damage to be repaired. Place to which defective or damaged item of plant is to be taken or repaired. Transportation to be used and insurance cover for such transportation. Okay, so what we said about this material, so you can remove that after you take permission from employer or engineer, So place to which defective metal, okay, we take it testing off, okay, proposed inspection and testing off site, let me read it again because I just kept silent for a few seconds. Let me read it again, doesn't make much difference. Remove any item such plant from site for purpose of repair, contractor shall give notice with reasons to engineer requesting consent to remove defective or damaged item of site. This notice shall clearly identified item of defective or damaged plant and shall give details of defect or damage to be repaired, place to which defective or damaged item of plant is to be taken for repair, transportation to be used and insurance cover for such transportation, proposed inspections and testing of site and plant duration required before repaired items of plant shall be returned to site. The contractor shall also provide any further details that employer may reasonably require. Now replace any items of such plant and or materials. Contractor shall give a notice with reasons to engineer, clearly identifying item of plant and or materials to be replaced and giving details of due date of delivery to site of replacement items. Where item of plant and or material has become property of employer under this subclause before it has been delivered to site, contractor shall ensure that such an item is not moved except for delivery to site. Contractor shall indemnify and hold employer harmless. Contractor shall indemnify and hold employers harmless against and from consequences of any defect in title or encumbrance or charge, except any reasonable restriction arising from intellectual property rights of manufacturer or producer or any item of plant and or materials that has become property of employer under this subclause. Now, additional subclause. If contract is being financed by institution whose rules or policies require a restriction on use of funds, a further subclause may be added. Example, all goods shall have, this is example subclause for goods from eligible source of countries. All goods shall have their own origin in eligible source. Now, all goods shall have their origin in eligible source countries as defined in insert name of published guidelines for procurement. Goods shall be transported by carriers from those eligible source countries unless exempted by employer in writing on basis of potential excessive cost or delays. Surety, insurance and banking services shall be provided by insurer and bankers from eligible source countries. Then clause 8, commencement, delays and suspension. Commencement, delays and suspension. Subclause 8.2, time for completion. If works are to be completed and taken over, in stages, it is important that each stage is defined as a section and time for completion of each section is stated in contract data. Please also see guidelines below. Okay. Now, subclause 8.3, program. It is strongly recommended that programming software that is preferable to engineer in his or her monitoring of contractor's progress in executing works be clearly identified in specifications, and that such software is drawn to attention of tenderers in instruction to tenderers. For less complex projects, employer may consider simplifying requirements for contractor's program as listed in subparagraph A to K in this subclause. For example, by replacing subparagraphs A to K in this subclause with subparagraphs A to D as they appear under subclause 8.3, program of FIDIC's conditions of contract for construction. Okay. Subclause 8.5, extension of time for completion. Extension of time for completion. Subparagraph C of this subclause entitles contractor to an extension of time for completion for exceptional adverse climatic conditions It may be preferable to set out in specifications what constitutes an exceptionally adverse event, for example, by reference to available weather statistics and return periods. It may also be appropriate to compare adverse climatic conditions that have been encountered with frequency which events of similar adversity have previously occurred at a near site. For example, an exceptional degree of adversity might be regarded as one which has a probability of occurrence of once every 4 or 5 times for completion of works, and example once every 8 or 10 8 to 10 years for 2-year contract. Now, final paragraph of this subclause provides that rules and procedures for assessing contractors' entitlement to extension of time where there is concurrency between delays attributed to both parties shall be stated in special provisions. This provision has been drafted by FIDIC in this manner because there is one standard set of rules procedures in use internationally, though for small example approach given in delay and disruption protocol published by Society of Construction Law. Now, in preparing special provisions, therefore, it is strongly recommended that employer be advised by a professional with extensive experience. Okay, let's see how does. In preparing special provisions, therefore, it is strongly recommended that employer be advised by a professional with extensive experience in construction programming, analysis of delays, and assessment or extension of time in context of governing law of contract. Now, delay damages, subclause 8.8, delay damages 8.8. Under laws of many countries, or other jurisdictions, amount of these predefined damages must be a reasonable estimate of anticipated or actual loss caused to employer by delay. Therefore, if delay damages are fixed at a reasonable large amount, they may be unforeseeable in common law jurisdiction. They may be unenforceable in common law jurisdiction, or subject to downward adjustment in civil law jurisdiction. If accepted contract amount is to be quoted as sum of figures in more than one currency, it may be preferable to define these damages per day as percentage to be applied to each of these figures. If accepted contract amount is expressed in local currency, damages per day may either be defined as a percentage or be defined as a figure in local currency. Additional subclauses. Now, incentives for an early completion may be included in addition to subparagraph of subclause 13.2 value engineering, which refers to accelerated completion. Example, subclause for incentives for early completion. Sorry. Contractors shall be entitled to a bonus payment if works or each section is completed earlier than time for completion for works or section. As case may be, amount of bonus for early completion of works and or each section is stated in specification. For purpose of calculating bonus payment, applicable time for completion stated in contract data is fixed and no adjustment of this time by reason of granting an extension time will be allowed. Now, clause 9, test on completion. Test on completion, subclause 9.1, contractor's obligation. Specification should describe tests which this contractor should carry out before being entitled to taking over certificate. May also be appropriate for contractor's proposal to include detailed arrangements, instrumentation, etc. Works are to be tested and taken over in sections. It is strongly recommended that consideration is given to testing requirements in a specification that take due account of effect of other parts of works being incomplete. For less complex projects, employer may consider simplifying testing requirements under subclause clause 10. Now, employers taking over. Subclause 10, employers taking over works and sections. If works are to be completed and taken over in stages, it's important that each stage is defined as a section in contract data. Precise geographical definitions are advisable, and contract data should include a table to also define for each section. Relevant percentage for release of retention money or time for completion and applicable delay damages. An example form of this subtable is shown in example form of contract data included in publication. Clause 11, defects after taking over. Defects after taking over. Depending on complexity of project and nature of works, employer may consider amending period of 2 years stated at end of first paragraph of this subclause to be longer or shorter period. Subclause 11.10, unfulfilled obligations. It may be necessary to review effect of this subclause in relation to period of liability imposed by applicable law. Now, unfulfilled obligations. It may be necessary to review effect of this subclause in relation to period of liability imposed by applicable law. In particular, second paragraph of this subclause may require amending to take account of applicable law. Now, additional subclause. If works include a plant that and comprises in whole or in part new or innovative technology in country or at employer's location, consideration may be given to including in specification a requirement for contractor to provide supervisory assistance to 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 employer permanent operating personnel in operation and unfulfilled obligations, it may be necessary to review effect of this subclause in relation to period of liability imposed by applicable law. In particular, the second paragraph of this subclause may require amending to take account of applicable law. Additional subclause: if work including plant and comprise in whole or part new or innovative technology in country or at employer's location, consideration may be given to including in specification requirement for contractor to provide supervisory assistance to employer's permanent operating personnel in operation and maintenance of plant during DNP of works. Examples of subclause for supervisory assistance during defect notification period DNP. Contractor shall provide supervisory assistance to employer during defects notification period DNP for works. Such supervisory assistance shall be as described in specifications for purpose of supporting employers operation and maintenance of plant for period of insert number of months after date of completion. Measurement and valuation. Works to be measured, clause 12.1. Works to be measured. If any part of permanent works are required to be measured according to records of construction, this part shall be identified and records to be made should be stated in specification. If contracted to be responsible for such records, this should be specified in contract by employer in specifications or by contracts in. Okay, then we have to go what should be measured. Variations and adjustments, clause 13. Variations can be initiated by any of three ways. Contractor may initiate his own proposals under subclause 13.2, that is value engineering, which are intended to benefit both parties. Engineer may instruct variation under subclause 13.3.1, variation by instruction. Engineer may request a proposal from contractor under subclause 13.3.2, variation by request for proposal. Now provisional sums. 13.4, provisional sums. Provisional sums may be required for parts of works which are not required to be priced at risk of contractor. For example, a provisional sum may be necessary to cover goods or services which employer wishes to select after award of contract, or to deal with a major uncertainty regarding subsurface conditions. It is essential to define the scope of each provisional sum. It is recommended that this be included in a schedule prepared by employer, since amount of each provisional sum corresponding to defined scope will then be excluded from either elements of accepted cost, the accepted contract amount. Adjustments for change in cost. Adjustment for changes in cost. Provision for adjustments under this subclass may be required if it would be unreasonable for contractor to bear risks of escalating costs due to inflation. Amounts payable to contractor are to be adjusted for rises or falls in cost related to labor, goods or other inputs to works. For this subclass is to apply, it is important that schedule or schedules of cost in taxation are included in contract and that such. All right, now if amount payable to contractor are to be adjusted for rises or falls in cost of labor, goods or other inputs to works, for this subclass to apply, it is important that schedule of cost indexation is included in contract and that such schedules include a formula for calculation of applicable adjustments under subclass. It is recommended employer be advised by professional with experience in construction cost and its inflationary effect on construction cost when preparing the contents of schedules of cost indexation. Schedules of cost change costs. Alright, now so schedule of cost, indexation, example formula for adjustment for changing cost. Now PN is adjustment multiplier to be applied to estimated cost value in relevant currency of work carried out in period N, this period being a month. Now A, small a, is a fixed coefficient representing non-adjustable portion in contractual payments. B, C and D are coefficients representing estimated proportion of each cost. Alright, now we'll move this way, right? How many articles are there? Let me see. Can we move today or we have to see? It means formula is there, A, B, C, D. A is fixed coefficient representing non-adjustable portion on contingent payment, whereas B, C and D are coefficients representing estimated proportion of each cost element related to execution of the works. Such tabulated cost elements may be indicative of resources such as labor, equipment and materials, and a particular care should be taken to calculation of weightings coefficients A, B and C. So I think it's long running contract price and payments. So we have to wait here. I think in running just for nothing, it doesn't mean anything. So what I say, better we hold here for tomorrow because it's already more than 4 hours. So of course a little this FIDIC 217, we studied this one today. This is still red book also, still not started, and we studied about this, and we studied about management, engineering management, and this is a very important point, and others also is the study continues and it will never end. But important is how much you understand on contracts, on engineering, on other issues, and also many other videos available. It depends upon people, what they think, what they do. There's no limit. Safety videos are available, engineering management videos are available, these videos are available, and many more. If you go through, it's up to you. I'm just trying to share with all whoever are interested to think of their future. We'll take this point tomorrow. This FIDIC wellness point also possibly, if it's time permits, we'll start silver book also, if it's possible. Otherwise, we'll take some other day. And of course, with that, I like to close this already, and so I close this now. I hope. Time is changing, life is changing, society is changing, world is changing, countries are changing, everything is changing. Drastic change is happening all around. What time comes, nobody knows. But whatever it is, one should be ready for whatever circumstances appear. And if you are not ready, you will certainly do something which must not be lost. And we should not be losing anything if we know. So I like to close it now. Thank you very much. See you tomorrow.